Last section is multiple angle formulas. So again, formula-based section, good news is you're not required to memorize the formula. You are required to understand the formula, plug into the formula, and either evaluate or simplify with the formula. Okay? So we're going to start with a set of formulas that are called double angle formulas. And yesterday we didn't have time in class for me to show a proof of one of the sum and difference formulas. If we have time on any of our review days, we might take a quick peek at that just to see, like, why is the sine of u plus v equal to the sine of u times the cosine v plus the cosine u times the sine of v. That's an interesting thing. Okay? You just accepted it yesterday. Ms. Cronky said it, so it's true. Thank you. The double angle formulas come from the sum and difference formulas, or really just the sum formulas, because double angle would mean something like two of the same angle. So, like if we're talking about angle u, it would be like u plus u. There's two of them. So let's derive the formulas, even though you don't have to have them memorized, but we're going to do the sine of u plus u. So this is from yesterday. We're using the sum formula. It just so happens that I'm changing it, so instead of u plus v, they're not two different angles, they're the same angle. But that's allowed. It could very well be the same angle. If you look at your foldable and you follow the formula for the sum of two angles, taking the sine, you're going to get something like sine of u times cosine u plus cosine u times sine of u. You okay with that? What do you notice about those two terms? They're really the same. It doesn't matter if you're doing sine u, cosine u, or cosine u, sine u. You can get the same thing, right? So then they're like terms. You can add them together. There are two of them. 2 sine u, cosine u. And that's equal to the sine of 2u. So here we're calling this a double angle formula because we're not just taking the sine of a single angle u, we're taking the sine of double u. 2 sine u, cosine u. Okay, so we could do the same thing with cosine. Instead of cosine of u plus v, we'll do cosine of u plus u. Cosine's formula starts with cosine times a cosine times a cosine. So we're going to say cosine u times cosine u. And then if we're doing the double angle, so we're adding the u's, we'll put a subtraction sign. And then we'll have the product of the signs. Sine u times sine u. Well, we could simplify that a little bit. Cosine u times cosine u could be written as cosine squared u. And then minus sine squared u. Seems kind of reminiscent of your Pythagorean identity, but it's not sine squared plus cosine squared, so it's not equal to 1. It's equal to the cosine of 2u. So that's another formula. Now, on your test, on your quiz, you will see cosine of 2u written 3 ways. So this has a version where you have a cosine squared and a sine squared, but we could substitute with our Pythagorean identities, and then we would have it cosine of 2u in terms of one trig function on the other side, either cosine squared or just sine squared. So we're going to do 2 substitutions here. Okay. Cosine of 2u equals cosine squared u minus, and in place of sine squared we could put 1 minus cosine squared. Okay, so this is a Pythagorean identity. 1 minus cosine squared. if you were to distribute that negative, that's like plus a -1 and then plus a positive cosine squared. So how many cosine squareds do you really have? 2. So we could say the cosine of 2u is equal to 2 cosine squared u minus 1. So this is like an or. If you want everything to be in cosines, then use that version of cosine of 2u. And we could make another one. This time we'll sub in for the cosine squared. We'll put in 1 minus sine squared. So we do that again. Cosine of 2u equals, we're going to replace, this is back to the original double angle formula. We're going to replace cosine with 1 minus sine squared u, and then finish out the formula, minus sine squared u. I don't have to worry about distributing a negative there. I just see how many sine squared u's do I have. 2, and they're both negative. So I would write my formula as cosine 2u equals 1 minus 2 sine squared u. Okay, so for cosine 2u, you have 3 different formulas. If you want a cosine squared and a sine squared, use that original one. Most often, you're probably going to choose one of these. I want everything in cosines, or I want everything in sines. So then you choose the one that you want. Okay, last one. Tangent of u plus u. I'm going to go ahead and let you try to derive that formula by plugging it into your sum formula from yesterday. You're doing a good job. You're just following the formula from yesterday. Top numerator should look like tangent u plus tangent u. So then I have 2 tangent u's in the numerator. In the denominator should look like 1 minus tangent u times tangent u. So that's 1 minus tangent squared. And this is equal to tangent of 2u. Okay, so essentially there are 3 double angle formulas. However, we rewrote the cosine formula using our Pythagorean identity. So we actually have, 5 double angle formulas? All 5 will be shown on the quiz and test. So those things are provided for you. You can then choose from that list. All right, how are we going to use the double angle formulas? We can solve equations. So cosine of 2x plus cosine of x is equal to 0. And we want to solve in the interval from 0 to 2 pi. Have to be careful, and this is going to be a little bit tricky, so hopefully you've been practicing your 5-3 and doing those homework assignments, because you have to have like an eagle eye for this and see that the cosine of 2x is not at all really like the cosine of x. So I can't combine them in any way. I can't factor out a cosine of x from both of them because they don't both have a cosine of x. They're 2 totally different cosines because you're doing one for a single angle and one for a double angle. Okay. So you gotta have that eagle eye, and when you see something like cosine of 2x, think about the double angle formula. Okay, and I'm gonna flip back to my previous slide on my screen. And I'm gonna look at my cosine of 2u. I have three options. I could put in a cosine squared minus a sine squared. I could do 2 cosine squared minus 1, or I could do 1 minus sine squared. Which one of those do you think will be most beneficial in our equation? Tegan says? Which one? The second one, with only cosine. So we'll introduce a cosine squared. Okay, so we're going to use our double angle formula right here, and we're going to say, I always have a hard time, is it 2 cosine squared minus 1? Yes. So 2 cosine squared, and then this is x, minus 1, so that's in place of cosine of 2x. Keep my cosine of x, and then like Tegan said, you've created a trinomial that's all in cosines. And even though cosine squared and cosine are not the same, we still can work with those because we can factor. So if it's helpful, I might rearrange this line, 2 cosine x plus cosine x minus 1. That's kind of like in standard form, highest exponent in descending order. And then I just have to think about how to factor. To get the first term of 2 cosine squared, I must be multiplying 2 cosine x and a cosine x. Stop and make sure. If you were to multiply those two terms together, do you get 2 cosine squared x? Yes, you do. I then jump to the back. To get a negative 1, I have to multiply a positive and a negative 1, so I can at least drop my 1's in. And then I have to choose positive and negative. I'm going to use my middle term to help me. I need it to be a positive cosine x. So when I do outside, I'm going to get 2 cosine x. When I do inside, I'm going to get 1 cosine x. So I need this outside one to be positive. So you need to be thoughtful when you're factoring and make sure it's really going to give you the thing that it was. And then after you factor, make them both equal to 0. Why don't you do that real quick, like our solving equations from 5-3, see if you can get the answers from 0 to 2 pi. I'm getting pi thirds, 5 pi thirds, and pi. You agree with my solutions?
Yeah.
5 pi thirds coordinate is 1/2 comma negative square root 3 over 2. So its cosine is also 1/2. And 5 pi thirds fits in that interval from 0 to 2 pi. Any other questions? Okay, so remember, you got to have an eagle eye coming into the quiz and the test. You have solving from 5-3, where we saw 2 x's, but they weren't mixed in with regular, like you didn't have a sine of 2x and a sine of x in the same problem. So when you see that you have a double angle and a regular trig function, you're going to have to use the double angle formulas. Okay, also another use for double angles that you'll see on your homework assignment are just these problems like rewriting an expression. So this looks like 3 minus 6 times sine squared x. Could be negative 6 sine squared x plus 3, but what do you notice about those two terms? They both have a factor of 3. So you could factor out a 3, you get 1 minus 2 sine squared x. And then 1 minus 2 sine squared x is really just cosine of 2u, which in this case would be cosine of 2x. So it's just like, can you manipulate that expression to make it look like one of your formulas from today? So you'll have some practice with that in the homework assignment. One other one, and this one's a good one to look at, can you rewrite 10 times sine of 2x and cosine of 2x? I like where Saban went with that. You have to use that one formula because it looks most like which double angle formula? The first one we did. Sine of 2u is equal to 2 sine u cosine u, right? That's the one it looks most like. So what you need to do is think about, okay, how can I get a 2 out front? You could take out a 2, but then it would have a 5 in front of the sine and the cosine. So instead of taking out a 2, take out a 5. So factor out the 5, break it up. We saw these two x's in 5-3. They're trapped in a group of parentheses. You can't undo or factor out the 2 or divide by 2 or do anything like that. They're trapped in there. What this means is, in terms of this, it now looks like 2 sine u cosine u, but what is u? 2x. U is 2x. So you have to be on the lookout for that. So when I go back to simplifying to that first one, it's the sine of 2 times u, then it's the sine of 2 times 2x, which is the sine of 4x. So you'll have 5 times the sine of 4x. Have to be careful on those substitutions. That shows up in calculus. Gotta make sure that you're actually putting in what the u is. It might not always be just x. It might be 2x. So then you put in 2x. Okay? Now, we have another set of formulas that will be included on the quiz and test. So again, you're not responsible for knowing these formulas, but you need to know how to use them. They're called power reducing formulas. And they come from the double angle formulas. So the double angle formulas came from yesterday's formula. Power reducing comes from the formulas we just did. And hopefully at some point we'll have a moment where we can prove one of the sum and difference formulas. So like we have a proof of why those work, and then all of this other stuff is true. Okay, power reducing. Power reducing means if you had a sine squared x that has a power greater than 1, you want to reduce so there is no square. You could have other exponents. It could be like sine to the 4th x. Then you want to use your power reducing formulas, so it's not sine to the 4th or sine squared, it's just sine. Okay, so that's what power reducing formulas are going to do. I'm going to go real quick right back to the double angle formulas that we derived at the very beginning. Look at your double angle formulas. The first one, sine of 2u, doesn't have any powers greater than 1. Okay. Second one does. And we're going to focus on the 2 that we manipulated, because I've got a cosine of 2u, which has no power other than 1. But then I have a cosine squared. So what we're going to do is we're going to take this formula and we're going to isolate the cosine squared. So we're going to add 1 and divide by 2. That's a power reducing formula. And then we'll do the same thing for the other version. We'll solve for what sine squared is equal to. We're going to have to subtract 1 and divide by negative 2. Okay. So let's do that. Let's write down the first double angle. Cosine 2u equals 2 cosine squared minus 1. Cosine 2u equals 2 cosine squared u minus 1. To create the power reducing formula, we're just going to isolate cosine squared. So I would add 1, cosine 2u plus 1, and then I would have to divide by 2. So that's equal to cosine squared u. If you ever have cosine squareds and you're asked to reduce the powers, then you use this formula here on the left. And we do the same thing for sine, because this has a power of 1, the cosine of 2u. It is a double angle, but it has a power of 1.
So you want to turn it from the right to the left. Oh, so you got
Yeah.
substitute.
Yeah.
I was like, what am I supposed to do with that?
So this is the left side normally, cosine squared. You're going to plug it into the other side. Okay, the other one is cosine of 2u is 1 minus 2 sine squared u. So this time we're going to get the sine squared all by itself. What would we have to do? Cosine 2u minus 1 over negative 2, and that's equal to sine squared u. And then I'm going to clean this up. Rather than have negative 2 in the denominator, if I were to divide these two, the cosine of 2u would be negative, divided by negative 2. And the negative 1 divided by negative 2 would be positive. So I'm just going to flip-flop my numerator. 1 minus cosine 2u over 2 equals sine squared u. Now, for the tangent, we're actually going to use one of our identities from earlier in the chapter. If you look at like the tangent sum formula, or sorry, the tangent double angle formula, I mean, we could attempt to solve for tangent squared, but it's not going to be real nice. It's in the denominator there. So probably a better way to get your power reducing for tangent squared is to think about it as your quotient identity. It's really sine squared divided by cosine squared. And then we just said sine squared is 1 minus cosine 2u over 2. And I would divide it by the cosine squared. But by dividing by the cosine squared, I'd really be multiplying by this reciprocal. So times 2 over cosine 2u plus 1. And then what happens real nicely for you? The 2's will cancel. So then we can say our tangent squared power reducing formula is just 1 minus cosine 2u over cosine 2u minus 1, or sorry, plus 1. Now nothing in that's going to cancel because they don't really share a common factor. And so then that would be as good as it is. Okay. You don't have to worry about deriving the formulas necessarily. Okay. So what we're doing here in our notes You won't have to do that. You'll just be using the formulas, okay? But it's nice for us to look at to see why things are the way they are. Okay. And we'll do one example with the power reducing formulas because you'll have some examples on your homework. So this is what the power reducing problems will look like. They'll say something like, rewrite sine to the fourth x in terms of first powers of the cosines of multiple angles. So here it's like really like comprehend your directions. What are they asking me to do? In terms of first powers, sine to the fourth is not acceptable. That's not in first power.
So the sine one you did, is that supposed to be like the first sine thing rather than?
I'm not really certain what you mean. This sine thing that I did?
Yeah.
Sine squared u?
So that one goes with like the sine
Yes.
and u equals u.
No. It came from our cosine of 2u. These formulas are not derived from the sum formulas. They're derived from the double angle formulas. So we picked the double angle of cosine because it had a sine squared in it, and we just isolated sine squared. Okay. But we are going to use that formula, 1 minus cosine 2u over 2. Okay. But we have sine to the fourth. So first, we need to rewrite it as sine squared. It's really sine squared x times sine squared x. Wouldn't that be sine to the fourth? Yes. Then you can use your power reducing formula. 1 minus cosine of 2u. What's u? Yes. And now be careful, if it was 2x, then you'll have to change that. Okay, but here we'll just say cosine x over 2 squared. I'm going to write it out because we're going to have to multiply it. So I'm going to FOIL the top. I'm going to get 1 times 1 is 1. I'm going to do my outside and insides together. Negative cosine x, negative cosine x. Negative 2 cosine x. And then a negative cosine x times a negative cosine x. Positive cosine squared x. All over 4. Okay. Did I not write my equation right? This is 2x, isn't it? Sorry. I dropped those when I have all my formulas up here, so I look at them. So if you do the formula wrong, then you're out of luck, right? So we should have all those as 2x's. Okay, and what was cool was, when we first wrote them, we didn't have any other powers. But now I FOILed it out, and I have another square. So I have to do power reducing again. So I've got to use my power reducing for cosine. Okay, so tell me for cosine squared u, is it cosine 2x plus 1?
Yeah.
Okay, cosine 2x plus 1 over 2. Okay, so we want to put that in here. What's our u now? 2x. So when I put that in, oops, this should be a u over here. When I put that in, it's going to be cosine 2 times 2x, so it's really going to be cosine 4x plus 1 over 2, all over 4. And we're almost there. We have created something not nice, right? A fraction inside of a fraction. So this is the same tip that I gave people yesterday who did the tangent with the square root of 3/3. To just get rid of this 2, we're just going to multiply this whole numerator by 2. But if we multiply the numerator of our fraction by 2, then we have to multiply the denominator by 2. Good.
Just try not to.
Good. No, I appreciate it. 2 times 1 is 2. 2 times 2 cosine 2x is 4 cosine 2x. You're only going to multiply the coefficient. Don't worry about that 4x. It's protected by parentheses. And then when you multiply this last term, multiplying by 2 only cancels it out. So it's plus cosine 4x plus 1. All over 8. And then you can clean that up because 2 plus 1 is 3. And now when you look at all your cosines, they have like a double angle, and then we're doing 4x, but they don't have any powers. Okay? And this would be an advantage in calculus, that you could reduce the powers. Okay? Now, side note, Bob, the back of the book, I don't really refer to him very often, but Bob is probably going to write it as 1/8 times the numerator. I accept this answer up here. So if you want to leave it as a fraction, that's okay. So if you see those strange things in Bob, he's just factoring out the fraction in the denominator. Okay, those power reducing, those are ones you need to like be real thoughtful, be real focused when you're practicing those, because you've got to pay attention at that moment when you redo it, and you have to pay attention to what your U is. So make sure when you're plugging into your power reducing, you have thoughts. Is U really X? Is it 2X? Is it 3X, 4X? Okay. Work your homework. You're going to have a quiz tomorrow. Stop in today after school if you have questions. I'll see you tomorrow.